After studying this module, you would be able to derive the relationship between AR, MR and elasticity. You would be able to understand the application of the concept of elasticity in taxation. You would be able to understand the application of elasticity in minimum wage determination and understand the application of elasticity in energy pricing. Now, let us study the relationship between AR, MR and elasticity. This is a very crucial relationship that exists between the three, and this is extensively used in the theory of pricing and in practice as well. The relationship is expressed as follows: AR is equal to MR bracket E, which is elasticity, price elasticity of demand, divided by 1 minus E bracket closed. Okay. Therefore, AR and MR are related to each other through a factor which is E upon 1 minus E. The above formula can be derived with the help of the following geometry. Look at what you see is that on the y-axis we are measuring price, that is AR and MR, and on the x-axis we are measuring the quantity. We have output or quantity. Now let us consider the AR function, which starts from B and slopes downwards, and just below that you would notice that there is the MR function which also starts from B and also slopes downwards. But you would notice that the MR function falls much steeper, much faster than the AR function. Consider a price P. At this point, if we draw a line which goes and intersects both the MR and AR, you would have 2 points R which intersects the MR function and S which goes and touches the AR function. That is, at this point again, that is at point S, if we drop a perpendicular, then it would go on to the x-axis, and then we have a point A at which this perpendicular intersects the MR. This shows the height of the marginal revenue at point S, which is the point which corresponds to the price level OP. Now, considering, keeping these things in mind, now let us look at the price elasticity. According to the point elasticity of demand, we know that the lower segment upon the upper segment is equal to the elasticity. So, SC upon SB, this would give you the price elasticity of demand at point S. So, now if we consider SC upon SB equal to SQ upon PB, and this is because of the property of similar triangles, since SQC and BPS are similar triangles. Okay. So, now if we consider these two, then what we can see is that elasticity is equal to SQ upon PB, which is equal to SQ upon SA, which is then equal to SQ upon SQ minus AQ, and which is also then equal to SQ stands for average revenue, and if we substitute, then we get that AR upon AR minus MR, and so the equation tells us that elasticity of demand is equal to AR upon AR minus MR. But AQ is the marginal revenue and SQ is the average revenue corresponding to point B. Therefore, at OQ level of output can be written as E is equal to AR upon MR. Equation 2 can be rewritten. So, we can transform this equation. AR, we take it onto AR minus MR onto the other side. So it becomes AR is equal to E within bracket AR minus MR, and therefore if we just open up this bracket, it becomes E into AR minus E into MR, and if we further simplify by taking MR onto the left hand side and we transform it, then the relationship between MR and AR becomes that MR is equal to AR into with bracket 1 minus 1 upon E. So these are sort of interchangeable equations in which we can at one time look at the relationship in terms of AR, and at a different point we can look at it in terms of MR. And now if we now look at the midpoint where we know that the elasticity is equal to 1, then what will happen is that you could see very clearly in equation 2, if you substitute the elasticity being equal to 1, then it would read as MR is equal to AR within brackets 1 minus 1 upon 1, which is 0, and this entire equation becomes equal to 0, therefore MR becomes equal to 0. So what does it mean? That when MR is equal to 0, then we can clearly see that the elasticity on the demand function, which is our BSC, on this demand function, if we consider the marginal revenue to be 0, then the elasticity would be equal to 1. We have worked it out on the basis of the midpoint, which lies exactly above the point where the MR goes and touches the x-axis, thus MR is 0. Now if we consider some other values, for example MR is equal to 10, which is AR, and the elasticity is, in brackets we have got 2 minus 1 upon 2, so therefore MR becomes 5, and then for elasticity equal to 1, of course we have already argued that the marginal revenue would be equal to 0. So what does this point to us? That if marginal revenue is 0, then beyond this point marginal revenue can actually never become negative. So therefore this is a kind of a limitation on the quantity that can be produced if we are talking about a downward sloping demand curve for a non-competitive producer. We will be seeing more of this later on. So now what we can say is that we can show that on every point of the demand curve where the elasticity is greater than 1, MR is positive but less than the AR. Further, at every point on the demand curve where the elasticity is less than unity, MR is negative. So we can show that every point on the demand curve where elasticity is greater than 1, the MR is positive but it is less than the AR. Further, at the point where elasticity is 1, there the MR is 0, it is still declining but it is above, it is above the negative axis, so it is 0. Now beyond this what happens is that when the elasticity is less than 1 on the straight line demand curve, then what happens is MR becomes negative. So when the MR is negative, then at this point it is not possible for the producer to determine production. So any increase in the price would actually increase the total revenue if the producer is operating on the demand curve which is above the midpoint. So the elasticity of demand is greater than 1. So this is a property that the tendency of the producer would be that if price falls by a little bit, the quantity demanded would increase more than proportionately. So the total revenue will increase. So between the point B and point S, the tendency of the producer should be to reduce the price, because the elasticity is greater than 1, and therefore for every reduction in the price, the total revenue is likely to increase. At the point S, where the elasticity is exactly equal to 1, beyond this point it does not pay for the producer to reduce the price, because if the quantity demanded goes beyond the point where MR intersects the x-axis, then this is a point where production cannot take place. And this is what we mean by saying, in the case of a downward sloping demand curve, this is what we mean by saying that a monopolist who has got a downward sloping demand curve will always operate on that portion which is over and above the midpoint, that is on the elastic portion of the demand curve. Therefore, it is important to understand the policy implications. The policy implications are clear, that the MR function drops twice as fast as the AR function, and the producer can go on reducing the price and increasing the quantity being produced and offered, as long as the elasticity remains greater than 1. But the moment it becomes equal to 1, this is a threshold at which the minimum price that a producer fixes when the demand curve is downward sloping. Remember, we are not talking about a perfectly competitive firm in this case. So, considering this, we would now understand that the relationship between AR and MR, although it is a demand curve, but this is a demand curve which a monopolistic firm may be facing, and then these are the typical decisions that the managers face, and they have to decide what they do about the prices. Now let us look at some applications. Now first of all, we are considering the application of elasticity in the determination of the impact of taxes on prices and quantities. Government imposes taxes on a wide variety of commodities. It could be cigarettes, alcohol, imported goods, and so on. We are interested in knowing that when the government imposes such a tax, who is the entity, which is the entity which actually bears the burden of the tax. This is known as incidence of tax. For understanding this, we must understand what the underlying demand and supply conditions look like. Let us take an example. Suppose a tax is imposed on petroleum. In 2008, an average tax on petroleum was, let us say, 50 paisa per gallon. Many economists and industrialists proposed to raise the petrol tax, and they were of the opinion that the higher the tax increment would be, the oil consumption, petroleum consumption would go down, and therefore it would also be beneficial to global warming, that is to reduce global warming. Moreover, it was expected that it would reduce the dependence on the import of oil. So they proposed an increment from, it was expected that the price of oil should go up by about 1 to 2 rupees per liter. Now we want to know what would be the impact of such a change and who would bear the incidence of a tax. For a concrete study, let us assume that the government decides to reduce the oil consumption by levying a charge of 2 rupees per liter, and the legislators would be uh, reluctant in the first place to raise the uh, the tax, but they want to know that who are the whether the firms would be affected by this or whether the consumers would be affected. That is, as we have said, who is the ultimate entity on whom this impact would be felt. So, the exact effect of the increment in tax can now be used looking at the supply and demand conditions. In figure 3, what you would see is that we have an initial supply function SS. On the x-axis we have quantity, on the y-axis we have the price of petrol, and suppose the price increases by let us say 2 rupees or 200 paise, and then the marginal cost would increase, and when the marginal cost increases, then you would notice that the supply function is going up from SS to S prime S prime. The demand curve remains the same, that is DD, and the intersection of the demand and supply functions take place respectively. The original intersection is at point E and the new intersection is at point E prime. Now, if we look at the situation where the new equilibrium is taking place, and if we drop a perpendicular, then what we would see is the original price was 70, okay, and now if we look at the new price, it is 71.8. Now, if we consider what has happened to the 2 rupees increase, then you would notice that 1 rupee 80 paise is the escalation of the price, which is going towards increasing the retail price. And if you look at the the change that is taking place below the original price, then as far as the producers are concerned, the price that they are receiving is 69.80. That means there is a reduction of 20 paise. So, that means out of the increase in the tax to the tune of 2 rupees or 200 paise, 180 paise is being borne by the consumer, and 0.2 of a rupee or 20 paise is being borne by the producer. The impact, of course, is as expected, that because of the tax, the quantity of petroleum or petrol which is used has gone down from 100 to, let us say, 80. So, there are various impacts. On the one hand, the price, the market price, the retail price has gone up. On the other hand, the realization of the producers has gone down. The quantity consumed and sold has gone down, which was an intended purpose of the policy. But one interesting thing is that the price does not go up by the full amount of the tax. This is because there is an interplay between the elasticity of supply and elasticity of demand. If the elasticity of demand is low, then the major portion of the tax would be borne by the consumer. And if the elasticity of supply is low, then we would have a situation where the major part of the increase in the tax would be borne by the producers. In this diagram, what we see is the elasticity of supply is, that means that the supply curve is quite elastic, and therefore the producers are having to bear only 20 paise. and the demand curve is quite steep, it is vertical. So the consumers are having to bear 1 rupee 80 paise out of the additional tax. So what we see is that in the application of elasticity to the policies, that is like taxation, we see that there are various aspects and we are able to clearly identify the impact of such a tax in terms of discouraging the use of petroleum, in terms of the incidence of the tax, and all of this is derived and depends upon the elasticity of demand and elasticity of supply. Now let us look at another example. We now consider an application of elasticities to the pricing of oil during a situation where the oil prices were skyrocketing. Now it is important that for a developing economy like India, we could not afford such high prices. So if you look at figure 4, you would notice that there is a ceiling which is imposed on the oil price at rupees 20. Whereas if we look at the market price, it should have been 30. Now, but at this low price, what we notice is there is an excess demand. And this excess demand would create a pressure in the market, and it is likely to disturb the normal operation of the market for petrol. So therefore, it is important that demand and supply is matched, and this can be done only if there is a control in terms of rationing the amount of petrol that can be given to each vehicle owner. Otherwise, if the open market forces are allowed, then what will happen in this situation is that the price might actually go up to 50 rupees, which would be very damaging. So this again relates to the question of the elasticities of the commodities, because petroleum is a product for which the demand is quite inelastic. Therefore, even the imposition of a ceiling price may not actually solve the problem. We are now going on to another application, which is about minimum wage determination. At certain times what happens is, if there is a recession in the economy, then the wages may turn out to be very low, and this would be quite detrimental to the workforce. Now we consider figure 5. In this case we have a supply function, that is supply of labor, and a demand function, which is demand for labor. And now if we were to allow the market forces to operate, then the equilibrium would take place at M. At M, what we find is that the market wage W market is pretty low, and this would mean that the employment is also low and the wages are also low. So the workers would not be happy with this situation. But this is because there is a temporary period where the demand for labor has gone down, and therefore the wage rate has also gone down. So has employment gone down. Now, as against this, if as an intervention in the labor market, if the government retains a minimum wage called W min, at this point you would notice that the total workforce that could be employed could go up to LF, and this would reduce the possible unemployment which might be precipitated due to extremely low wage rate in the market. So this way the supply exists, so labor force would be forthcoming, at a higher wage, okay, but at a higher wage obviously the demand would be less. So there has to be some negotiation with the firms, and then this gap that you would see which is designated as this gap has to be somehow fulfilled. Now, finally, let us summarize what we have studied. The elasticity of demand, as we know, measures the responsiveness of price, quantity to price. We have already seen how it is estimated. But there are interesting policy implications if we examine certain related aspects. That is, average revenue AR and MR are related to each other. What we can see is when AR falls, MR also falls, but there is a point at which MR becomes negative, and beyond this point the production cannot take place. So we would like to use our knowledge of or our understanding of elasticity, and then what we see is that there is a definite relationship between AR and MR through elasticity, that is AR is equal to MR into E upon 1 minus E. This points out to the fact that where the elasticity is equal to 1 and above that point, on the demand function, on the AR function, production can take place, prices could be reduced or increased according to the conditions that the producer is facing. But beyond this, beyond the point where elasticity becomes unitary, that means if elasticity becomes less than 1, then it is not possible for the producer to reduce the price further. Then we have seen a few applications in terms of taxation, in terms of pricing of petroleum and other such commodities which are necessities, and then we have also seen how in the case of elasticity or through elasticity we could also understand the implications for minimum wages. So these are some of the applications of demand and supply and elasticity.